Welcome to this video, where we'll explore a fascinating topic in computer graphics, making a mesh invisible while still allowing it to write to a custom depth buffer. This technique has many practical applications in fields like game development, simulation, and visualization. Imagine being able to hide objects from view while still utilizing their geometric information for advanced rendering effects or simulations. Sounds intriguing. That's what we'll be diving into today. In this video, we'll delve into the world of computer graphics and uncover the secrets behind making a mesh invisible, yet still functional. By the end of this discussion, you'll have a solid understanding of the concepts and steps involved in achieving this effect. To begin with, let's define what a mesh is. A mesh is essentially a collection of vertices, edges, and faces that together form a 3D object. In computer graphics, meshes are used to represent objects in a scene, allowing us to render them on the screen. Now, making a mesh invisible might seem straightforward. Simply don't draw it. However, this approach would also prevent the mesh from writing to the custom depth buffer, which is crucial for advanced rendering techniques like ray marching or ambient occlusion. So, how do we achieve this seemingly contradictory goal? The key lies in exploiting the way graphics pipelines work. You see, when a mesh is rendered, it goes through several stages: vertex processing, clipping, and finally, fragment processing. Here's where things get interesting. We can leverage the fact that the depth buffer is typically updated during the early stages of the pipeline, specifically during vertex processing. This means we can still write to the custom depth buffer even if the mesh itself isn't visible. To accomplish this, we'll need to employ a few clever tricks. Firstly, we can set the mesh's render mode to depth only, which tells the graphics engine to only update the depth buffer without rendering the actual mesh. Next, we'll need to ensure that our custom depth buffer is properly configured and bound to the correct frame buffer attachment. This might involve some platform-specific code or shader programming, but don't worry too much about those details. Just remember that we're working with a custom depth buffer here. Now let's talk about the actual writing process. When the mesh goes through vertex processing, we can use the resulting transformed vertices to compute the desired depth values and write them to our custom depth buffer. To illustrate this concept better, imagine you're rendering a complex scene with many transparent objects. You could use this technique to pre-pass the invisible meshes, updating the depth buffer accordingly, before finally rendering the visible objects on top. Let's quickly recap what we've covered so far. Making a mesh invisible doesn't necessarily mean it can't write to the custom depth buffer. We can exploit the graphics pipeline stages to achieve this effect. Setting the render mode to depth only allows us to update the depth buffer without rendering the mesh. Properly configuring and binding the custom depth buffer is crucial. We've explored an innovative technique for making meshes invisible while still allowing them to contribute to a custom depth buffer. This approach opens up new possibilities for advanced rendering effects, simulations, and visualizations. If you have any questions or would like further clarification on this topic, please leave a comment below. Don't forget to like this video if you found it informative, and consider subscribing for more in-depth content on computer graphics and related topics. As always, we appreciate your engagement and look forward to continuing the conversation.